Folks, welcome to another video for 1064. Today we're going to dive into a very important topic in terms of fundamental ideas of programming, and that's the idea of objects. We've been talking about objects all along. We've said that every variable we ever create is represented as an object. We keep using those terms. So the variable x I just declare here stores an integer, in this case the value 13. But that entire entity is represented as what we call an object. Every list we create is represented as an object. And we have methods that we could apply to objects of in various ways to get them to do things for us, to behave in various ways. And that's all we're talking about today, except instead of referring to a predefined integer object or a predefined list object, we're going to create our own type of object called a class, defined by something called a class, to be able to create these kinds of new objects, user-defined objects. So let's say, for instance, we wanted to represent a playing card that has a rank and a suit, like the King of Spades, that kind of thing. So if we were to do it without writing our own class, what would we do? We could declare a variable and give it a value. We could say that a card has a rank and give it a value. But really, those two things are part of one bigger entity, right? These two things together help define the concept of a playing card. And we could come up with other ways of grouping them together, putting them in a list or a tuple, for instance, and that kind of thing can serve, that kind of approach can serve fine depending on exactly what you're doing. But today we're going to tackle this problem by defining a class. So the first thing we will do is put the class header up there, and we're going to define a single definition called a card that will represent a playing card. So class is a keyword of the Python language. You declare a card, you define its definition, you define a class, its definition, using the keyword class, the name of the class, you can name it whatever you want. By convention, classes start with an uppercase letter, and if there are multiple words, every word starts with an uppercase letter, followed by a colon, and then all the contents of the body of the class are indented, just like statements are indented in functions, and statements are indented inside an if statement body, that kind of thing. Same principle here. Everything indented under the class header is part of that class. So the dominant things you find in a class are functions. So I'm going to put a function definition in here, but the name of this function is going to be double underscore 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 init underscore underscore. So two underscores before init and two underscores after. It's going to take parameters that I'll call self, rank, and suit. We'll dissect all of this in just a second. So that's a function header for a very strange looking function name. The reason it's named that way we'll discuss. And three parameters, self, rank, and suit. And then inside this function, I'm going to say self.rank equals rank, and self.suit equals suit. Let me just leave that there for the moment. We'll come back and dissect all this in a second. I'm going to also create another function here, another double underscore function. Sometimes, as the book points out, these are called dunder methods, special methods that have the double underscore before and after the name. This one is called string, double underscore string, and it is only going to take the self parameter. And in this case, I'm going to return. The init method didn't return anything. This one's going to return, and I'm going to say self.rank concatenated with of, with spaces around it, concatenated it with self.suit. Okay. That's the entire definition of the card class as I'm going to define it. This is, by the way, an example that is part of the reading for this week. It's a particularly good example in terms of pointing out all the various characteristics I want to show. So I'm kind of just walking through the examples in that particular topic and pointing things out as we go. There are several good topics with examples of class definitions in them this week. Okay, so these dunder methods, in particular init and string, str, serve a special purpose when it comes to the definition of a class. By the way, functions inside a class, we've said this before in the abstract, but here we are defining one. A function that's defined within a class is called a method. So I may kind of go back and forth calling them methods and functions. They're all functions, but a function that's declared inside a class or that's part of an object is called a method. So we have the init method, the dunder init method, and the dunder string method. Okay, so these have the double underscore in their name to kind of help set them apart, to make it easy to understand that these are special methods that serve a special purpose. And the init, the dunder init method, serves to create the instance data you're going to use for the object, the values you're going to represent in that object. And in this case, a card has a rank and a suit. And so what I'm doing in this function is I'm accepting the rank that's passed in when I create the object and setting it equal to self.rank. I'm storing it in the instance data that's referred to as self.rank. And then the same thing for the suit. The suit is passed in as a parameter as an argument to when the object is created. So I might pass in spades, for instance, for the suit of this particular card, and I'm storing that in these variables that are prefaced by the self dot reference to indicate that these are instance variables, instance data maintained by this object for the duration of its existence. So let's talk about self just for a moment. The self reference is a special reference. Again, its role, it always shows up as the first parameter to any of the methods that are defined within a class. You don't explicitly pass them in when they're called. You don't even have to call it self, although you should, because that's a convention that everybody has gotten used to, and it makes it very clear what's going on. And it's also very well named, because what self refers to is this object, the object that is executing the code at this moment. It's a reference to itself. Now that's potentially a little confusing. So let me just pause for a moment here. I'm going to save this in a module I'll just simply call card.py. I'm going to put that up on my desktop. All right, so there's card.py, and it contains the definition of a class. We still got more to say about this. I want to come back to the whole idea of self, but that'll it'll be a lot easier to talk about once I talk about using this card class now that I have it defined. So I'm going to create another file, and I'll save it as card.demo.py. And this is just going to be a regular Python program that I'm going to use the card class in. So since card is defined out here in a different module, a different Python source code file, I need to import it just like you would import any of the modules you might need from the Python standard library. There's nothing magical about that process. All that means is that what you need is defined in another file. And so over here, I can say import card, the name of the module, the name of the file, not the name of the class within it that you need. And we'll come back and talk about the import statement in just a second as well. So I'm importing everything that's in this module, which happens to be just this card definition, the class definition. Classes are often defined in their own modules, their own files, so that they can be reused, so that they can be imported into any particular program that needs to make use of them. Okay, so by importing card here, I have access to the card class, and any other program that needs the card class could do the same thing. Okay, so let's create a card object. I'll call it card1 equals card, paren. So this is the process of creating a card. I specify the name of the class, which is capital C card. In this case, I'm going to need to preface it with the module name. You've done that many times, math.square-root, for instance. Same principle here. The module is card, and I'm referring to the thing called capital C card, the class, in that module. We'll see later how we can modify the import statement so that I don't have to bother doing that. But let's leave it that way for now. All right, and when I create a card, I'm going to pass in the rank and the suit. So let's pass in, I don't know, the Jack of Hearts. All right, so that's defining a card object. It's creating a card object, which I'm storing in a variable called card1. Let's create another card, card2 equals card.capital C card. And let's make this the 4 of clubs. All right. Now, I have two perfectly good card objects here. No different than when you've created many other objects in the past. It's just that I'm using a user-defined class, a class I've defined myself. So the class defines the concept of the card. And here I am creating an actual object of that card twice over now. I can create, now that I have the definition of a card, I can create as many card objects as I'd like. In fact, I might create 52 of them and have a deck of cards. We'll do that in just a second. So here's the point. This is creating a particular card from the definition, the blueprint of the card, defined by the class, and I'm passing in some particular data that this card is going to hold on to. Pass in the Jack of hearts in this case. Let's go back to the card definition. Sorry, let me go back here. When this call is made, when I create the card object, this will automatically call the init function, the init method of the card class to initialize the data that I'm storing in that object. So in this case, I'm passing in the Jack of Hearts, and card 1 is keeping track of those pieces of information. Card 2, made from the exact same template, the exact same class, is storing different data, so it represents the 4 of clubs. Okay? Let's go back to the card definition. So when that card is created, the init dunder method, special method, is automatically called, passing along the rank and suit values. The self reference is not explicitly referred to out here. When you're using an object, I don't ever have to refer to self. We'll come back to that. And so what's happening? The rank that I happen to be passing in is stored in something called self.rank. Myself, the self, the object that I'm referring to, the object that's being set up right now, that object's rank gets assigned to the rank value that I pass in. So here's this definition of the init method. It's defined only once in the blueprint in the card class, but every time I create a card, the same init method is called, but I end up storing the values in that card's instance data. Every object you create is referred to as an instance of a particular class. So this is the card 1 variable is referring to an object of type card, and so card 1 is an instance, refers to an instance of the card class. Card 2 also refers to an instance of the card class. Each instance is a separate object, and each object has its own instance data. It would have to. Every card has a unique, for instance, rank and suit. And so I would want that. I need separate memory space in every object to store those values. But over here in the definition, we just define that one time. And that's why we refer to it as self.rank. This guy's rank. This guy's suit. Okay? Takes a little bit to wrap your brain around that idea, but the idea is simply that this template, this blueprint, is created once. We only have to write the class once, and it applies to all the cards that I ever create from that template, from that blueprint. Okay? It becomes a little more comfortable the more you play around with these. We'll come back to the string idea in just a second. Let's do a couple of things with these cards we've created. I'm going to say print card1.suit. See what happens when I run this. All right, I have some errors here. Let's see what we got. Aha. No, let's see. The problem is I misspelled retrun. Return is what that should be. Save that. Let's go back here, try this again. Okay, there we go. Let me clear this, run it again. I'm printing the suit of this card, and sure enough, card 1's suit was set up to be hearts. I could print card2.suit, run it again. Hearts, the suit of this card, and clubs, the suit of this card. So I don't just talk about any suit. I'm talking about the suit of a particular card. And that makes sense, right? Every card has its own particular suit. So I don't talk about suit in the abstract. I talk about a particular suit of a particular card. And I, of course, could do the same thing with the other piece of instance data. I could print card 2's rank, for instance. Run that, and the rank of card 2 is 4. Okay, so that's how I can access the instance data that's stored within a particular card. What if I do this? Print card 1. Not card1.suit or card1.rank. Print the whole object. Let's see what happens there. Run it. Get the other output, and then I get Jack of Hearts. Jack of Hearts. When I print card 1, and that is the Jack of Hearts, but where does that come from? Going back to our card class, it comes from that's the purpose of this other Dunder special method, the string method. His role in life, just like the init method's role is to initialize the data that's stored in the card, the role of the string method is to return a string-based description of that object. Now, we could write this to return whatever we want. In this case, I wrote it so that it would return the rank, the word of, with spaces around it, and then the suit. So, 4, or Jack of Hearts in this case. Right? 4 of clubs, whatever it happens to be. That's a reasonable description of this card. But when we write the string class, we can define it to be whatever we want, whatever textual description of the card you want. So I can refer to individual elements within the object, like card1.suit or card2.rank, or I can refer to the entire object. And in this case, when you print a card, what happens is the code of the print function, when it's handed an object, calls the string method behind the scenes, and whatever it gets back, that's what it prints. Right? So in most cases, when you define a class, in most cases you'll define at least the init method to initialize the data and a string method to provide a representation of that object. And in the case of this particular class, that's all I'm going to define. I could go on to define other methods that serve as behaviors for a card, various things that a card could do, like maybe being able to compare itself to another card to decide whether it beats that card, or whatever kind of functionality is appropriate for the problem you're trying to solve. But for now, I'm going to leave this definition of a card just to these two standard methods. All right, so this demo is, this little program is creating a couple of cards and printing some information out about them. All right, let's take this then a step forward. Let's create another class. I'm going to create another separate file here that I'm going to call simply deck of cards and define it as its own deck of cards and define it as its own class so that I can create an object that represents an entire deck of cards. I already have a class that represents one card, so now I'm going to create a class that represents an entire deck of cards. I'll save this one as deck _of cards.py. All right, so what should we put in our deck of cards class? Well, as I said, almost every class you ever write has an init method a dunder init method. I'll pass in self, but nothing else for a deck of cards. And we'll see why in just a second. So whatever I put here is going to set up my deck of cards. Then I can create whatever other methods that I'd like. So what is going to be a deck of cards? How am I going to represent a whole set, a whole class, or a whole list, essentially, of cards, of card objects? Well, I'm going to do it exactly that, exactly as a list. So I'm going to say self.deck is a list variable, an empty list initially, and that's going to be the sum total of my instance data for a deck of cards. Deck of cards is going to have a variable. It's going to keep track of a variable called deck that represents an entire list of card objects. So what is init going to do to fill up that list with all the possible cards I might create? Well, what are the cards? Let's create a couple of separate lists to help us kind of get this job done. What are the suits, for instance? We got clubs, we got diamonds, we've got hearts, and we got spades. Those are the 4 suits. Now we have a lot more ranks, but let's go ahead and put those into a list as well. And I'm going to create these all as strings, even though some of them are numbers. It's just going to be all represented as strings, and I'll just use the simple digit to represent it. Could spell it out, I suppose. So 2, 3, 4, 5, 6, 7, 8, 9. I'll come down to the next line. 10. And then after 10 is what? Jack, Queen, King, and I'll put ace here at the end above king. So those are my 13 ranks and 4 clubs, 4 suits. And so when you combine every possible rank and suit combination, you get your 52 standard deck of cards. But these are 2 separate lists that I'm going to use to help fill this deck. These are just really local variables to the init function, the init method, and they're going to go away after we call init. But the thing that's going to stick around is the deck. So how can I use these lists to create all the possible cards? I'm going to use a nested for loop. I'm going to say for every suit every possible suit, for every suit in suits, the list of suits, for each one of those, I'm going to then say for every rank in ranks. And I'm doing that as a nested loop. So what do I want to do? I want to update self.deck. I want to add something to that list. So if you remember, the append method is how you add something to a list. And what is it I want to append? I want this to be a list of card objects. The card of the card class that we've created over here. So I'm going to say for every suit and for every rank, create a card object from that, let's see, rank and suit. I got to put them in the right order in terms of the parameters. And that's what I'm going to append to the deck list that I've set up as my instance data. All right, I think that's it for my init method. When I create a deck of cards object, the init initializer will be run. It will create a unique variable called deck, self.deck. The deck is stored inside this particular object. And then the rest of this code is just setting up and filling this deck with a whole bunch of card objects, one from every possible combination of suits and ranks. So suit will go clubs, diamonds, hearts, spades. And while it's clubs, the very first one in, it will do all of the possible ranks. So it'll create the 2 of clubs and create that card and put it in the deck. Then it'll create the 3 of clubs and put that in the deck. And then the 4 of clubs and put that in the deck. Go through all the rank for clubs. Then we're done with that inner loop. Go back out to the outer loop. The suit takes on the next suit, which is diamonds, and then does all the ranks for diamonds. 2 of diamonds, 3 of diamonds, 4 of diamonds. Creates cards for all those. Then hearts and spades, all the possible combinations. All right. Let's see. Let's go ahead and define the other Dunder method that we've seen before, the string method. Again, the methods always take as their first parameter the self-reference, even if you don't have other parameters under arguments passed into this particular method. For the string output, I'm going to print all of the cards in the deck. I'm going to return, I should say. Keep in mind the string method returns a string. What you do with that string is up to you. So I'm going to create a variable called deck string and initialize it to nothing initially. And then say for every card in the deck, give me some space here. For every card in the deck, append to the deck string variable, concatenate to it, a string representation of that card, followed by, so they're not all on the same line, followed by the new line character. And then once that loop is complete and all the cards have been put into that one big string, I'll return the deck string. Okay. So once again, there's only 2 methods in this class so far. We're going to come back and add some others to this particular one in just a second. And the only 2 that I have are the Dunder methods, init and string. Init sets up the deck. String creates a big string that contains all the cards in the deck and returns it. So once again, I'm going to create, like the book does, I'm going to create a separate demo. Let's see, let's save this as deck of cards demo.py. I believe that's what the book calls it. And here's where I'm going to create and play around with deck of card objects, or create one particular deck of card object. So let's see. I need to import it, and this time I'm going to use the from clause of the import statement and say from deck of cards, from the module, the file deck of cards, import the deck of cards class, the definition of deck of cards. And what this does is, by using this from clause, this allows me to not have to append the deck of cards reference with the module name every time. So instead of saying, let's see, deck equals deck of cards dot deck of cards, instead of, because I've used the from, I don't have to put this part in. So that cleans up, simplifies your code a little bit. So you might want to get comfortable with the with that version of the import statement. We've used it maybe a couple of times in the past. I just wanted to point it out. Okay, so this is my program that's going to create a deck of cards object, and in this case I'm calling it deck. What should we do? What if I print deck? What's that going to do? I created the object and then I immediately print the object itself. Well, we said last time that when you print an object, what the print function actually prints is whatever the string function returns to be printed. It returns the print function when it's called here. The code of the print function calls the string function, the string method of the deck object, gets back a string and prints that. And that's the guy that we created just a second ago that contains all the cards in the deck, each on a new line. So let's see if that does what we think that will do. Run it. I got an error here in deck of cards.py. Aha, right, because I referred to card, the card class, but I've never imported it. So just like I imported the card module here when I wanted to use cards, I have to also import it when I define it, when I use it as part of my deck of cards class. So again, I'm going to use the from card import capital C card, and that way I can just use it by its name and not have to say card.card the way we did here. Okay, so that's the difference between this version of the import and this version of the import. Okay, so that's to address that error that came up. I'm going to come back over here and run this, and there we go. We get our output, and it's a lot of output. So let me scroll back to the beginning. I ran deckofcards.demo, and all that did was create a deck of cards and print the entire deck. And so the print method called the string, the print function called the string method of the deck, which returned all the card strings one at a time on a separate line. And look, they're in the order in which I created them. The double for loop, the nested for loop, created them in this order. 2 of clubs, 3 of clubs, 4 of clubs, all the way down to the ace of clubs. Then it turns to diamonds. 2 of diamonds, 3 of diamonds, 4 of diamonds, all the way up. And then all the hearts, and then all the spades. And that's all 52 cards in the deck. All right, let me clear that out, give myself some room here again. So that's doing nothing more than creating one deck of card object and printing it out. Well, if that's all I can do with a deck of cards, that's not terribly useful. In fact, the fact that when I create the deck of cards, they're all in a particular order is not typically helpful. So let me go down and add some more methods to the deck of cards class to make a deck of cards object a little more useful, a little more helpful. I'm going to create, what if I want to shuffle the deck? This is an actual easy one because I can just make use of the random shuffle method, if you remember. Random.shuffle. And then whatever it is you want to shuffle, in this case, the deck. So that's a one-liner that will end up shuffling all of the elements in this list into a random order. And that's all I need to do. So now I've defined another method, another behavior that a deck of cards object can do for us. So let's go out here and see if that's the case. Before, when I created the deck of cards and then printed it, it of course printed all of them in the order in which they were created. But what if in between there, I say, hey, deck dot shuffle. Shuffle yourself, right? Shuffle the deck, and then print it. Let's see what that looks like when I run it. Aha, another error, because over here I used the random module, but once again didn't import it. So I'm going to just simply import random. Then this reference will make sense. And back to this, run it. There we go. All right. So this time I created the deck of cards, which creates them in a particular order, but then I shuffled the deck, and then when I print the deck, it's in whatever shuffled order it ended up in. So the 9 of diamonds is at the top of the deck, then the ace of clubs, jack of diamonds, etc. And still all of the cards will be represented. The shuffle simply change the order of them randomly as they exist in the list, which is exactly what you want to do to shuffle the deck. All right, so that's another behavior that the deck of cards class and object will now do for us. Let's do another one. What if I wanted to deal a card? I'll make a method called deal card. Again, no parameters, no arguments necessary to get the job done. Let's see. I'm going to return a card, and the question is, which card should I return? I'm going to deal a card. I'm going to take a card out of the deck, off the top of the deck, right? I'm dealing from the top of the deck. I'm going to take one card off the top of the deck and return it to whoever called, to the calling function. So how can I do that? Well, card, I'll set equal to, how do I remove something from a list? Self.deck.pop, and the one I want to pop is the guy at the top of the list, which is at index 0. Okay, so I'm going to pop the card that's at the top of the deck, which actually removes it from the list. So I'm not going to have 52 cards in my deck anymore. I'm only going to have 51. And I set that equal to a variable, which I then return. So back in my demo program, after I print the entire deck, I'm going to print a blank line, and then I'm going to say card equals deck.deal card, and then I could print that card, and that should be whatever card's at the top of the deck after it's been shuffled. And keep in mind, every time I run this program, it's going to shuffle them randomly, so it's not going to be this same list every time. It's going to be a random ordering to the entire deck. So I don't know which card I'm going to get after I shuffle the deck and then deal the cards. Let's see, I printed a blank line here. Let's do this. Let me do it this way. Print deal some cards. Just to separate it out from the regular list of the entire deck that I printed. All right, let's see what that gets us. All right. So here's the entire this run of the program. Shuffled the cards into this order. The first one happens to be 2 of spades, then the 10 of spades, then the 6 of spades, then the king of hearts, etc. This is the order in which they are in the deck. And therefore, when I dealt one card off the deck, I got the first card off, and it's the 2 of spades, which I then printed out. All right. So I tell you what, instead of dealing one card, let's put this in a for loop for num in range, how many cards should we deal? Let's deal 10 cards. Card is taken out, and I print the card. I suppose I could just say print, deal, card, but let's keep it set up this way. Okay, so this time I'm going to deal 10 cards off the top of the deck, and it should be the same 10 that we see when we print the entire deck, the first 10 of the list. Again, give me some more room here to see. Here's my entire list. Starts with 7 of hearts, Jack of clubs, 8 of clubs, etc. And then when I went to, after I created the deck, shuffled it, and printed the entire deck out, I'm going to deal some cards. And sure enough, I'm getting the first 10 cards off the top of the deck one at a time. Okay? The 7 of hearts is at index 0 of the deck, so it was popped, and then I printed it out. And then now the Jack of clubs is at position 0, so I dealt him, popped him off, and printed it, and so on and so on and so on. So now there were 52 cards in my original deck, and then I dealt these 10 cards, so now there's only 42. How can we verify that? Let's go back to the deck of cards class and give it yet another behavior, yet another function, method that we could make use of if we want to. For instance, what if I wanted to know the size of the deck, the number of cards that are in the deck at this point in time? Well, that's as easy as saying return the length, the current length of the deck. That tells me how many things, in this case how many cards, are in the deck. So now that I have that new behavior defined for my deck of cards object, I'm going to come back up here. Let's see. After I print the deck, I'm going to print number of cards in the deck, colon, and print what? Deck dot size, the size of the deck. Then I'm going to deal the 10 cards. I'm going to copy and paste that exact same line down here. So up here I should see that there's 52 cards in the deck. And then after I've dealt 10 of them, there should only be 42 cards left in the deck. Let's see if that works out the way we think it will. Something's not right. Indentation error is not happy in the size method that I wrote. Def size. What did I do wrong here? Oh, one extra space there. It's enough to throw it off. Ah, the extra space is up here. That's why. Now I think I might be right. Sorry, let's save that and then run this guy again. I'm going to clear this all out. Start fresh. Run it again. And sure enough, after I print the entire list, the entire deck, as originally created, there are 52 cards in the deck. Then I dealt the cards, and now there's only 42 in the deck. So having the deck be able to report to me its current size, how many particular elements are in the deck, how many particular objects, how many cards are in the deck, then that's another behavior that might come in handy. So as I create the deck class, the deck of cards class, I can add whatever methods, whatever behaviors I think is appropriate to define a particular object. you as the designer of a class get to decide what methods, what behaviors that objects of those types are going to be able to pull off. Okay, let's do one more thing. This is something the book does that I think is a good point to make. Instead of just popping, if I deal the cards and I keep popping, well, what happens if I deal all the cards out and I have no cards left, and then I go to pop the deck to deal a card, and there is no card there? This is going to blow up, right? This is going to generate an error because there is nothing to pop. So let's guard against that. Let's say that the card I return is equal to the special value none. We've talked about that a couple of times, but here's we're using it for a good purpose. And instead of assuming that there's a card to deal, I'm going to check first. I'm going to say if the length of the deck, self.deck, the length of that deck is greater than 0, then the card can be the one that I pop off the top. So card is initially set to none, and if there's no cards left, then it'll stay none, and that's what I return. However, if there is something in there still to deal, then I'll deal it out as I did before and return that. So those are the kind of things special situations you always want to consider when you're writing the methods of a class to guard against kind of strange situations that you might get into depending on the way the program plays out. All right, what else should we say about this? By the way, the deck of cards demo program used a variable called deck, and the deck of cards class used a variable called deck, the self.deck. Keep in mind that those are two completely different things. It makes sense to call them both deck because they both represent the deck. But in this case, this is representing a deck as a list of cards that I end up putting it in, and that's instance data of the deck of card objects that I create. Whereas over here, this variable deck is the actual object of type deck of cards. It's a deck of cards object that I can then call the various methods of as needed to do whatever it is I want to do. So the fact that I've called those two things deck, don't let that bother you. That's actually two different scopes, right? One's defined in the class, the other's defined in this program here, and in one sense they have nothing to do with each other. Okay, I think that hits the highlights that I want to refer to. I've basically walked you through the guts of the example in that one topic for this week's reading. But read it again carefully and make sure it all makes sense. Then there's several other example objects, class definitions to look at as well. And by the time you get through all of them, hopefully the concept of a class defining an object will sit well with you. This class, again, is a very simple class that only basically holds on to two values and kind of stores them as a unit because I want to deal with them as one entity, as one card. The rank and the suit values, while those are separate things, together they define one particular card. And that's all I really needed at this level, was to define those, to define a card as having those two pieces. Whereas the deck of cards class was much more interesting, much more involved, had several other methods besides the init and string dunder methods. It had whatever methods we decided to add to it to to create the behaviors that I wanted the deck of cards class to have. Okay. Let me know if you have questions, and I'll see you next time. Thanks.